So we'll get started on photosynthesis. We're not going to get into the real detailed part of photosynthesis today. I think that's just a little too much biochemistry to swallow, but we'll look at the kind of big stuff in there. So photosynthesis is using light to make chemical energy, and you store that chemical energy in sugars. So that glucose, basically what you do is you use light and the energy from the light to glue carbon dioxide together to make the sugars. The same sugars that we eat, that we're usually getting from plant matter, are glued together by energy from the sun, is essentially what that is. So an autotroph is considered a self-feeder. They produce organic molecules from carbon dioxide and other inorganic raw materials from the environment. They don't have to consume any other living beings, so they're considered to be producers. They just produce organic material. Your heterotrophs, these obtain their organic materials by consuming compounds that are produced by other organisms. They're consumers. So we're considered a consumer in there because we have to eat something that something else alive made. So a photoautotroph uses light energy to derive the synthesis of organic molecules, specifically from carbon dioxide. So photosynthesis is going to occur in the chloroplasts. And as humans, we are animals, we do not have chloroplasts. Inside the chloroplasts, you're going to have chlorophyll, which is in the tissue of the interior leaf. The mesophyll is going to have these microscopic pores where carbon dioxide is going to be able to enter the leaves. So here you can see carbon dioxide can come in, and then you've got the chloroplasts in the mesophyll. So the stomata are actually, for some reason the notes are a little weird in here. The stomata are these openings, and they have fluid around them. You have dense fluid around this in the mesophyll, but the stomata are actually the openings that allow the gases to go through. So I don't know if that got changed in you guys' notes or not. Yeah. Occasionally I was typing these in the middle of the night and things like that happen. Look in the cabinets back there and just, I don't know where Harold put some of this stuff away, so that's what I will end up doing, is just opening and looking for them. It's not like you're going through my purse or something by opening the cabinets in here. So yeah, the stomata, and if you're looking, like if you work in healthcare already and you've seen people that have had like their colons removed and they have to have the bag, the stoma is the hole, stomatas are holes. So your roots are going to absorb the water, and they're going to get the water is going to get delivered up to the leaves through the veins. The thylakoids are going to be this system of interconnected membranous sacs that are going to segregate the stroma, which are the chlorophyll in the thylakoid membranes. And then you've got the grana or the granum, which are stacks of thylakoids that are going to be in some places. So down there, a little farther down in the picture, you can see the stroma around it here. Each of these is a thylakoid. The whole stack is a granum. So photosynthesis is essentially going to be the exact opposite reaction of what cellular respiration is. It doesn't have the exact opposite steps, but your net products are the exact opposite. So here you have 6 carbon dioxide, 12 waters that get glued together with light energy to make sugar, 6 oxygen and 6 waters out of it. So we use glucose to simplify the equation, but we actually make 3 carbon sugars. But it makes more sense if we look at it making glucose, so we can compare. All right, we make glucose with this one. We break down glucose to make the carbon dioxide over here. It completes our little cycle of life going in there. A lot nicer if we use glucose to make that. And I think that that is a good place to stop today.